ever since I was little, I've always been interested in engineering. My dad gave me a cordless drill when I was 6, and ever since then I've always been hands-on building stuff, and STEM has just kind of expanded upon that and has really let me go free, and with ROV and all the STEM classes that they offer, it really solidified my decision, not only my college decision, but my career decision as well, to be an engineer and to go to Berry and then transfer to Tech through the engineering program they have. And also the experience in the Southwire Engineering Academy has also really solidified my career choice, and it's given me real world experience in the engineering field, and I get to see what engineers do on a day-to-day basis, and it's definitely something I can see myself doing down the road.
Carrollton High School sent us a great batch of students. They're very intelligent, they're very bright, they seem like they're going to be very successful individuals. They're very excited to be here at Southwire. They're very excited to be working on the projects. They seem like they do very diligent work. Really good group of kids.
I agree, Charles. And in addition to the passion that's obviously there, and with the passion being there, they're going to take ownership, with the projects that we have for them. But there's also, I think, they're uniquely equipped just from an academic standpoint. The classes, both the sciences, the technologies, the engineering, the math, it uniquely qualifies them for the type projects that we are using these students, or having them involved. So I think the STEM background is a perfect fit for our Southwire Engineering Academy.
I can't say enough about our partnership with Southwire. Southwire is all in and just as committed to the program's success as we are. It quickly has become Carrollton High School's premier internship program and serves as the model for future endeavors with other companies. The significant difference between this relationship and others is its two-way nature. Our students are getting valuable real-world live work experience in the world of STEM, while Southwire's bottom line benefits from their efforts. It epitomizes the word partnership.
Our STEM classes teach students how to think. They are able to work and collaborate on projects, and our curriculum is based on real-world problems that students will encounter if they go into the field post-secondary or if they enter the workforce. They work on teams to analyze problems. They use math and science to more effectively create designs to solutions. And overall, it just gives students an idea of how engineers work in everyday life and how they collaborate.
STEM has had a really large impact on my life. It's basically helped me decide what I want to do when I grow up, which nowadays is super important, and everybody's saying that you need to know what you're doing when you go into college, and STEM has definitely helped me decide that I want to pursue some type of engineering or math or science degree. And a large part of STEM is definitely collaboration, especially in Southwire. I'm working in app development, and apps in general are kind of a collaborative effort.
We were very fortunate here at Carrollton. We have Superintendent Dr. Edwards, who does a phenomenal job, and his charge to us at the high school is to make sure that we produce a world-class education for our STEM students. And so with the support of Dr. Edwards, our Board of Education, Dr. Albertus, and then with the help of the grant that we got, we were able to purchase some really cool gadgets and machines for the kids to play with. And so now, through their experiences in our classes, dealing with these machines and these softwares that we're able to use, our industry leaders have come and told us how great it's been to be able to get kids that are graduating from Carrollton and using them as interns to be able to come out of high school and right into the workforce ready to go. Hey, welcome. It's great to be with y'all this afternoon. My name is Stacy Lawler, and I'm the assistant principal and CTA director at Carrollton High School. This is Miss Kasey Austin. She's our engineering instructor at Carrollton, and we're really excited to be here with you. STEM the Trojan Way, and we just take a lot of pride in STEM in our place. We really got started about 2009, 2010. We were fortunate enough, and we used to speak, folks would have us speak on the grant that we got. We got the Title IID grant back in 2010. It's not available anymore. but it was a grant for about $800,000. And this was as I was coming into the administration. Jason Mundorf was the CTA director at that time, and so all the equipment that we purchased, the professional development we went through, Kasey was involved with that, but it was another guy sitting in the chair when that was going on. But we've been very, very fortunate at Carrollton. Our STEM program goes K through 12. What we're talking about specifically today is our engineering program and our partnership with Southwire Engineering. But we are we want STEM throughout our school. We want from pre-K all the way to grade 12. And in a lot of different ways, a lot of variety of ways. One of the things is we want every kid to experience STEM if they want to. If they want to take a bite of the apple, we want them to have a bite of that apple. It's one of the problems. We're not a state certified school. We're not a state certified STEM school. If you love the rubric, you're welcome. We were the ones that caused that. We were. They came in to evaluate us before there was a rubric. We did not, for some reasons that they said, and about the next week, there's a rubric. And based on that rubric, we'll have a hard time being state certified because there's just 3 or 4 things on there that we're not willing to give up to do to meet it. And so we've found a different way to go about it. One of the things that we try to do is obviously we want our kids throughout the school to experience STEMs because they don't know. It's just like our engineering program. We have some really, really bright kids that they want to be engineers, but they really don't know what an engineer does. They don't know the different types of engineers, and they're problem solvers. And that's what we're trying to create at Carrollton High School all the way across. We've got some kids that they're not going to be your AP students. They're not going to be your IB students. They're not great students. They don't test well, but they can code their brains out. And so we want those kids to have those opportunities as well. At the junior high level, we have started surveying those kids, looking at test results, looking at their grades. We have a STEM program, a certificate that they can gain at the junior high school in the 7th and 8th grade so that when they get to the high school, if they complete that STEM certification, which it's classes that they take down there, then they get to move to the front of the line as far as signing up for our STEM classes, our engineering class in particular. Miss Austin's class, she's 180. I mean, she's busting at the seams, and so we don't have a lot of extra space in the engineering class, and so it's become a very popular pathway for folks to sign up for. We've really tried to focus on that. STEM at Carrollton, like I said, our elementary school is Georgia State certified. When we went through certification, we tried to get all of our schools certified. And the elementary school was the first elementary school in the state to become STEM certified. We're really proud of them. And so K through 12, we're doing different things to try. When we first started, our engineering was that was our platform. We tried to figure out what we wanted to do, and engineering was great for us because of all of the manufacturing that was around us. So we've got like I said, we've got the CNC mill, we've got the robotic arm, we've got the CNC router. We've got some different things that our kids can become experts on so that when they go out into the workforce, it's not the first time they've seen it. It's really kind of cool. We've got the smaller robotic arm like you see, and then we take them to the Honda plant, and they've got the big robotic arm. And it's the same robotic arm, it's just a big robotic arm. And so it helps them connect the dots a little bit. For us, in our engineering program, we use the VEX platform. We use that for the hook. One of the things that we did, and Miss Austin will show you a little bit when she's talking about our program, is we've got a big window that we cut out of her engineering lab, and we have a practice arena where the kids can see, because just about every kid going to the cafeteria is going to walk by that window, and they see those kids in there playing with those robots, with those controls in their hands, and it clicks with them. It's a hook. And they start talking about, I want that class, I want that pathway. And so it's worked really, really good for us. Our Southwire Engineering Academy has become one of our big things. It is one of the most sought out things at Carrollton High School now. It probably used to be cheerleader for the football team, and now Southwire Engineering Academy has picked it up, and I'll talk a lot more about that at the end. We're really working towards a capstone project for those 4th levels. We know what we're doing, pathways 1, 2, and 3. We have the Southwire Engineering Academy, but we're also wanting to add a class where they can create that capstone project like they would in college in that final year, in that final month. We have really focused on getting STEM throughout the school, wherever we can, every discipline, anywhere that we can stick it, that's what we're trying to do. And so we're constantly meeting. We've got a committee that we've put together from every discipline. And Ms. Holloway over here, she's our media specialist, and she helps me head up that committee. We meet personally throughout the year, but we're a Google platform school, which I'm sure a lot of you are. And so we do a lot of collaboration through Google and Google Drive and sharing ideas and working together to try to do that. Collaboration between departments to continue to develop rigorous cross-curricular authentic STEM activities. That's the goal of our committee. And we have, it was a hard sell at the beginning because a lot of folks, they just don't know. They don't know how to do it. And so for me, it was a lot of coming to conferences and getting on the internet and finding resources and getting those resources out and getting our best teachers to do best practices in faculty meetings. And so now it's second nature. We have a form on our Google Drive where they can go if they've got an activity that they do. We've got a little Google form that they fill it in, and now other teachers can go see it, or they can go back and they can recall from it. And so it's worked really good for us. One of my chief jobs is to try to get our program exposure. Georgia Trend magazine had an article about us a couple of years ago. We have STEM at a Glance that you can find on our website. And we have what we've done now. Do you mind clicking on the link for me, Ms. Austin? Ms. Holloway and I, we are now Advanced Ed STEM certified. SACS, for those of you that know SACS, we were the 18th school internationally to earn the Advanced Ed STEM certification. And so one of the things that we had to do is we had to document STEM throughout the school. And so Ms. Holloway, I was put in charge of doing that. I was put in charge of the STEM certification, and it took me about that quick to go recruit Ms. Holloway, because Ms. Holloway is a guru with Weebly and with web design and everything. And so we had to figure out a way that we could document what we were doing STEM-wise at Carrollton High School for the Advanced Ed STEM certification. And so what we wanted to create a live document that would be a breathing, living thing long after we went through the Advanced Ed STEM certification. And so this is our Weebly. We have a link for our Southwire Engineering Academy where you can find out any information that you want about our Southwire Engineering Academy. And then it's just a documentation through our educators, our teachers, what they do as far as preparing to do STEM, what our students are involved in, and then our partnerships, our outreach, and how we reach down to the elementary school and the middle school and the junior high school, and how they reach out to us. And so we now, after we went through that process, we have created a blog for that site. And so now what I've got anytime a teacher is doing anything STEM related, I have them send me pictures, send me video, send me a little blurb. And so we are constantly putting stuff on this so that 5 years from now, when we're having to go through recertification, it's done. We're not going to have to go back and put all the hard work, because Ms. Holloway and I basically for about 3 months locked ourselves in a room every day, and that's all we did all day long. It took forever. So this has been great. As of September 29th, 2015, like I said, we're an advanced ed learning STEM certified school, and it has been a great honor. This is one, if you're like us and you have a hard time meeting all of the criteria, this is one where you don't have to be perfect at everything you do. You can really play to your strengths, and you can work to improve your weaknesses, and your strengths can counter out those weaknesses. And so it's been a great thing for us. We're really proud of it. A couple of years ago, we had a system-wide STEM showcase where we invited our community all the way down. Miss Brooks down at the elementary school, we went down to the 4th grade. It was 4th through 12th. We took different things that our kids were doing. We invited in the community. We got some iPads that we were going to give away, and we brought the community in, the mamas and the daddies and the business partners, and we just let them see what we were doing at Carrollton City Schools. And it was just awesome. I mean, it was a great thing, and we're getting ready to have another one. This was not something we wanted to do every year because we didn't want it to become routine. And so we're going to try to do it every 4 or 5 years so that it's not a routine thing. It's something that's special, and folks are going to want to come to it every time. This was just some more pictures of it. Had a lot of interactive stuff for the small kids. Had a lot of prizes to give away. Got a lot of donations. A lot of buy-in from everybody, and so it was a school system-wide initiative. We participate in STEM Day every year. We try to every class. We try to get them to do something STEM on that day. Just to emphasize it, to show the kids that it's important, to show the teachers that it's important. The Georgia Trend magazine article, like I was telling you about. And then our engineering pathway, and I'm going to turn it over to Miss Austin to talk about her program, because it's kind of our hub. It is the thing, it's the cornerstone of what we're doing as far as STEM. And I'll tell you that the biggest thing you got to do is you got to get you a Miss Austin. She is the Pied Piper. You can have all of the equipment you want, you can have all the computers, you can have all the technology, all of that stuff. But if you don't have one that the kids are going to get behind and just hang on every word, that's where you got started. She is tremendous at what she does, and we really value her here at our school system.
Thanks for the introduction.
Yes, ma'am.
So I'm Kasey Austin. I've been at Carrollton for 7 years and been teaching STEM for 6 now. So we have seen a crop of ours graduate and go on to bigger and better things. But I just want to talk a little bit today about our engineering pathway, kind of some stuff we do that hopefully you can take back and implement in your school. And I know there's not a lot of like high school people here, but a lot of the stuff that we'll do and use is very applicable in like the middle school grades as well. I think the main thing is just going to be your safety and making sure kids know their way around some of the tools. But these are some of our students right here, and they're out and about in all different events, which is my first slide is STEM outside of the class. So I really feel like to get kids connected that they need those competitions outside the class. They need to interact with other adults. They need to present their ideas to people they're not comfortable with, and then get constructive feedback, and then always edit their work. So that's a big thing that I always push is, your work is never finished, and when you turn it in, you can still always edit it, always make it better, and try to relate it to real world. Like that's how companies run and work, and that's how business people, operate on a day-to-day basis. So these are just some pictures of some of, actually all of our VEX robotics teams. So is anybody familiar with VEX Robotics? Okay, great. So, it's a different game every year, and I have 4 teams, and anywhere from 30 to 50 kids combined of those 4 teams, so total. This is some more pictures of just trips we've taken. In the golf cart in the bottom right here, we got to go to the Kia plant, and they were so accommodating and nice. So if you have the opportunity to go travel somewhere, this place is great. They have manufacturing, they have it streamlined. They really kind of cater to the kids and take them through, because they want obviously the kids to remember their company and come back and work for them as well. This is us at, I do TSA, which is Technology Student Association. So this is us at one of the rallies, one of our fun days. And then this right here is our group we took to the West Georgia Technology, it's region specific. So ours was the West Georgia Technology Fair. And then tomorrow, actually, we're traveling to Macon to compete in the state technology fair. So they have each region's, I'm sure I Googled GA Tech Fair, and then it all comes up with all the different project categories you can enter. And then to be able to make it to state, all you have to do is win first place at the regional technology fair. So out of this crew right here, I'm taking about half of them to Macon tomorrow to present their projects there, and then they're up for potential scholarship awards and stuff like that. So we're hoping for a good turnout there. But I am a big believer that you need to get the kids out, and it does require a lot of Saturdays and traveling, but hopefully they're the good kids that want to go with you and don't make it hard on you. Another one of our team, so other than VEX, we have ROV, which is sponsored by the May Corporation, and they're government funded and research based, but it stands for Remotely Operated Vehicle, and what they do is pretty genius actually. They come up with these real world ideas, and they have these high schoolers build stuff to fix the ideas. Like, back in 2010, I think it was the oil spill challenge. So, they had to make an ROV that would go down to certain depths, cap an oil rig, take tests, bring back samples, analyze the samples, stuff like that. This is actually our 2012 team in Houston at the NASA Buoyancy Lab. So they won 3rd in the world at that competition, and that's the highest we've placed in the past 5 years. But that was a really strong team, and as you can see,
They beat Mississippi State that year.
yeah, they beat college kids that year. They were really proud of that. But it's a real world application, and this also allows them, they do not just build the robot and drive it and do the mission. They have to have a budget. They have to present it. They have to make a company name, and they have to assign roles, and they have to be able to speak about different components that they designed. And it's really cool to see your kids get involved in something like this. You know, a lot of the ones who kind of sit back, they'll really take pride in it and you know, really show out for you. But that's our remote operated vehicle team. And STEM camp is, I went to the camp invention class yesterday, which gave me a lot of good ideas. But for my fundraiser, you know, because robotics is expensive, and so for my fundraiser, the week after post planning, I get whoever of my high school kids are willing to help me, and we put on a STEM camp for, you know, K through 5. And we have them come in, and a lot of the stuff we do is kind of like camp invention. You can see here we're doing the water bottle rockets, and we're making slime and paper gliders and driving robots. But what we do is we charge the kids to come to the camp, and then, you know, free labor, my high school kids, and we get to reap the benefits of all of the money that comes in and spend it on our travel or whatever we need to buy for the team. So it's a great way to promote your program, but also generate funds. And then kind of the way our lab is, we're in the middle of building a new school, but we actually, when we first got the STEM grant, we didn't have a lot of square footage to work with, so we basically took over the old graphics lab plus another room, and it's kind of separated into 3 different sections. The first one is what he was talking about, where you can see from the hallway where a robot arena is set up, and it's a very functional space. You can use it for, you know, not only the vets, but also like project displays. So I think to have a place to display projects so that other students can see it is also helpful to, you know, get your program noticed and kind of see what you're doing.
Tell them about the platform.
What about it?
If you know about VEX, you know it's on the floor. One of the things that we did is we built a platform to get it up off the ground, which has made it so much easier for the kids as far as seeing.
Ergonomical, getting in and out, and like that. But this is our computer lab, so it's set up like not your traditional classroom. It's more conducive for collaboration. You see here they have a bench and a chair, so a lot of group work, a lot of working together. And then in the back is where we have our fabrication labs, where we have all our fun toys, but it's like safety zones. So, you know, obviously you go through all the safety procedures, safety quiz, walking them through before you let them loose back here. But I'll go through some of these pieces of equipment we have too. So just a few of my students showing off their work. This is the 3D printer we have. It's a Dimension, the Strayus Dimension printer, and it prints ABS plastic, and it has water-soluble support, which means you can make movable parts, which is really cool, because the one we had in the past, we just, you know, had to print the part individually and then construct it. But this has kind of been a game changer for, you know, moving wrenches, you know, moving axles, car parts and stuff like that. We've been able to print. And then this is one of my girls right here. I had to get her interested in it, so she loved art. I told her, you know, design your own art palette and print it out, so that's the result of her using it. Up at the top right, that's our laser engraver, which we got from Learning Labs, which is here in the vendors hall, but they're really nice to work with, and our laser engraver has brought us a lot of funds as well. Our debate team hosts a tournament every year. You know, they have about 500 people come to that tournament, and they print 150 awards, and we do them in-house. So by doing them in-house, it's saving the debate team money, because they were, you know, outsourcing them and paying a higher price. So, you know, we save them money, we get money, and then our kids actually work on something that's real world, something that like someone will take home and put on their wall. So that's also a buy-in for them, is if they know that their work is relevant and real, they'll spend a lot more time on it and a lot more attention to detail. And having tools like this, also if you teach CAD or any type of inventor software, it really kind of drives home the stuff that, you know, maybe your teacher told you that you were really like, or I know I did, like he's like, okay, start on 0, 0, and I was like, oh, that doesn't matter. But you know, when you go and actually put it on a machine, they can see why it matters, and then the math comes into play, and then a lot of really cool connections can be made. So yeah, I just said my role is kind of the facilitator, so I think it's okay to not have all the answers, as long as you're brave enough to try stuff. My level 3 right now, we're building derby car racers, and I've never built one of those before, but I'm like, it's kind of give it to the kids and let them do all the research, present it to you, and then you can kind of shoot down ideas or help them figure out what is best to do. But that's kind of how I like to run my classrooms, kind of let them be in charge of their own learning, have a lot of open-ended projects, because you've probably seen, if you give a kid something that's open-ended, they need an answer. They need to know, what does it look like? How do I build it, like step by step? But really, that's not real world most of the time. So giving them, a set of parameters, collection of materials, stuff, resources that they can, use to help them along the way, they can come up with the end design, and then that way they feel more invested in their learning, and also that they've created something that's completely original a lot of the times. So I teach the 3 different levels, and the first one's called Foundations of Engineering Technology, and I just have a few samples of projects that I do. And I'm sorry I don't have any of the sheets with me, but if you'll email me, I can definitely send them to you, like the project parameters, rubric, and all that good stuff. But the first thing I like to do, you can Google, that one's searchable, is the NASA Shoebox Design Challenge. I found it online. It's just they literally bring in a shoebox, and they have to make it have a positive glide slope ratio. You can do it at any age. The stuff that they can build, bring in to build is pretty much, there's no constraints. They can bring in whatever they think will make their shoebox glide the furthest, and it's really fun. This was my winner last year right here with her design and her partner. She really did all the work. He's just in the picture. But then I like to do Rube Goldberg machines. Again, you've probably seen this today. Do it at any age. It's a lot of fun. I have them actually come up with what the goal. So we use it when we talk about universal systems model, inputs, outputs, processes, feedback. And then I make them come up with what the goal of their machine is, and then we vote on it. It's something like take a selfie or pop a balloon or something like that. So then they have to build a machine within the criteria, that will do those things. And then I like to do this green rooftop challenge, where I was on a trip and kind of, in like Europe and a bunch of different places, they all have the green rooftops, and it's, because blah, 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 all the list of advantages you get from them. And then a lot of our kids don't even know that stuff like this exists, for engineers to do as a career. So it's a good way to kind of have them research where these green rooftop buildings are, how they're reducing the the carbon monoxide output, and then having them design their own, and then putting a cost to it, writing an essay on it, kind of like basically filling out a bid, like if you were going to bid a project. And then I've done it different ways. I've had them all use the same building, and they all have to design the exact same rooftop with the same square footage, and then I have them where they can make up what the rooftop looks like. So you can really have it evolve and tweak to whatever you need it to fit for your standards. And then the last one, which I'm about to start, it's the reverse engineering project. So, basically taking things apart, see how they work, telling them how engineers do this all the time. It started with even the iPod, how maybe Windows reverse engineered and figured out how they use that technology to create the iPod, and then Windows comes out with their own product. So a lot of talk about propriety and what is specific to you, what you own, and what people can still figure out that you've done from a product that you put out on the market. And I have them bring in stuff, some of them get really creative. Obviously the best thing to do is go to McDonald's and get the mechanical kids toys. That's good, especially for your middle school and lower. So they can take apart the mechanics of the kids' toy and see how it works, and then write a whole, brief of how it works, put together, and then you can do the inputs, outputs, processes, and feedback of that system. But I have mine bring in old toasters, old computers. A lot of them bring old cell phones and they want to take apart, and they identify and figure out how that stuff works. And then also my challenge at the end of this is to modify it or improve upon its system, to see if you can make something better out of it instead of just figuring out how it works. Then this is my level 2. Oh, and then in my level 1 I basically cover all of the CAD, how to draw an AutoCAD, an Inventor. Those are the primarily the two softwares that we work with at our school. And then when they move on to level 2, when I trust them a little bit, we start to use all of the tools and stuff that 10th graders are more prepared for than, let's say, 9th graders. But we do we start off with the robot, you know, it's just a simple VEX robot, and everybody builds the same, and we go through this curriculum. It's called REC, it's Robotics Engineering Curriculum. It's by Intelitech. When we first bought the grant, we partnered with them, and they kind of rolled out this plan for, they really have a great plan for, you know, STEM and all kinds of stuff you can bring in your classroom. But we use this platform, and it has each module, you know, you can skip through and obviously tweak it to what you want. But I had a guy met at a VEX competition. He was the bomb inspector for the GBI, retired, and I had him come in and talk about autonomous robots and how they use them in real life, and how a robot would need to go into a building that they have no idea what it looks like, no idea what they're going to encounter, and then try to, you know, discover or find out, you know, something about the area. And so that's where we kind of do our autonomous maze. Mine's obviously a little more simple. I make a maze, and they have to autonomously program their robot to go through it. And by autonomous meaning they can't drive it. It all needs to be programmed. So they have a hard time with that at first, but the results, they're always really proud of themselves when they get through the maze. Something else I do with the robots is called Sumo Bot, so that's kind of our physics lesson. I get the physics teacher to come in, and we talk about, you know, torque and gear ratio and how to build certain mechanisms to pull and push each other. So then they literally, exactly like what it sounds, they start and they try to push each other against the wall. You know, obviously you have to limit what each team has, because they fight about that. They're like, oh, they got more metal and theirs was heavier, but you know. And then Arduino and Makey I've used in level 2. Really I could use it in level 1 as well. And we start off by doing something simple like make a light blink. Okay, now simulate a traffic light. Okay, now simulate a traffic light with a sensor that can tell you're there. And then they go in and they write the code, and it's kind of like the evolution of learning how to code. Now, I don't know how to code that well. I just know enough to make what I have operate. But we have a computer science teacher down the hall, and he is like an expert at it. So if I ever get stuck, I always, you know, get him to help me out. But the last thing we do is I always start it after spring break, kind of like an end of the year fun thing. We do our trebuchet project. I started off with catapults, but what I was getting were slingshots, and so I stepped it up to trebuchets. So, you know, they have to actually do the counterweight and the sling arm and the whole release. And then again, our physics teacher helps a lot with, you know, providing some preliminary stuff like third-class levers, worksheets with loads, payloads, you know, try to estimate how far they think, and we sling water balloons, but then I make them estimate how far they think it will swing, you know, land on a water balloon, and then we actually do it, and then, you know, just plot all the data and look at, you know, stuff like standard deviation, make graphs of it, and try to figure out what the correlation is with all the data. And then this is my level 3, so these are my pathway completers. And by pathway completers, I mean, if you're not familiar with the process, they go through 3 sequential courses in one area, and then they take a test. And then the test is an industry-derived test. And whether or not they pass the test, basically, they'll get, like our school does, like a medallion, like a big medallion to wear around their neck at graduation to say, you know, I'm certified in engineering, or it's actually all of our CTA departments, broadcasting, culinary, graphics, web design, all that stuff. Some stuff I do with my STEM 3 is live work. They're number 3. So we have this big green router right here, and it is probably my biggest money generator right there. We have lots of school events that we'll make stuff for, or most recently we have a sports auction, and my kids are making a bunch of pieces to go to the sports auction to be auctioned off for, you know, $80, $100, $150, and when really it takes us like $30 to make it. So it's a great learning tool for the kids, because then, like I said, they can see what they draw to turn into something that's actually tangible, and then to sell it and kind of see how all that works. And then some of my high flyers, they are like awesome at like programming in Excel through our Southwire internship that you're going to talk about, right? Mm-hmm. And then I had him, you know, go ahead and cost out, okay, if the machine's life is, you know, 10 years, how much does it cost to run it per minute? And so he'll figure that out, and then figure out, you know, how much labor costs to go into the parts, and then how much the actual materials cost, and then just make me a nice little spreadsheet. So all I have to do is go in there and punch in how much material I use, you know, the square footage, and then his whole calculation is calculated, you know, everything else, you know, the machine running, the labor, and it just spits out this nice little price. It makes my life a lot easier. Which is another thing, that's what when I started, one of the teachers told me, whatever you can get the kids to do, get them to do it, you know. So I had a lot of my kids, you know, writing, for instance, letters to Southwire to get, you know, funded or donations, stuff like that, or writing just simple formulas that will help people, you know, running our live workstation. But then here you'll see these letters. We did this project last year. Our lunchroom ladies wanted some kind of continuity between the lunchrooms and have the letters for each school, so CES, CMS, CJHS. So that's what they're doing there. They're just making signs. And then up in the top left, this is another piece of equipment I got from IntelliTech. It's a 3-axis mill, and it works with the robotic arm to be like a flexible manufacturing system. So basically like automate a factory. So you could really program the mill to like drill, you know, a couple holes in a block and then have the arm come over, unload it from the mill, and then put it on these sensors to test it. You know, like so quality control, it can test if the holes are in the right spot, and then it can then sort, you know, good parts from bad parts. So just all the programming and, you know, work that goes into just doing that one simple thing will really take your kids like almost a half of a semester, just, you know, to learn how to use it, to program it, and then simulate a real world application. And then obviously I was talking about the derby car. So this will be the first time I've tried this, but for STEM Day this year, we're going to shoot for my class to produce 2 downhill derby racers, all gravity propelled. They just have to have brakes and steering. And then the physics teacher, his class is doing one, and then our architecture teacher, her class is doing one. So it should be fun and hopefully not dangerous at all. And then I just have some random shots from my classroom here, and I have high tech versus low tech because I don't think everything has to be super high tech. My kids are just as happy of building, you know, the tallest tower with popsicle sticks as they are to go cut something out on the router or program a robot. So, and I think the blend of that is also key to keeping them entertained because you're going to have strengths and weaknesses as you go through the year and as you do certain things. So having kind of like, I call it just like a break, you know, every time we finish a unit, we do like a fun classroom challenge. I usually just get on Pinterest and like figure out, oh, what can I have them build with this and this material, you know, whatever I have, and then just make a game out of it. And I always do it at the end of the unit because I give the winner, you know, an extra 15 points. So, you know, if they, like the last thing we did was they had to build, you know, a tower. It had to be like 4 feet high and hold a weight. And so if they built it 4 feet high, they got this grade, and then 3 feet, they got this grade. But if they won, they got the bonus points. So a lot of incentive and a lot of buy-in there. This is just something I did to have the kids kind of like a formative assessment, whether they thought different types of engineers were classified as mechanical, civil, chemical, or electrical. And so they would write like aerospace on one of the Post-it notes, and it's just set up like a Venn diagram, you know, so obviously one discipline can be more than one discipline. And they just go and kind of Post-it note on the board, and then I can, you know, kind of check and see how they're doing with that. This bottom right one's actually a tour that we went with the Southwire engineering interns to Georgia Tech, and they let us in their lab, and they were really, these graduate students, they just like come on in and we'll tell you all about our project. You can even get on it and write it. So they were really nice and really accommodating there. And Georgia Tech was really hard to get them to do a tour. But if you know an alumni that's willing to do it, a lot of the times they'll just let the alumni like, hey, yeah, sure, go and show them around. And so the alumni was actually the one who took us to these labs and introduced us to these grad students and kind of got our kids to see, you know, what's next.
All right.
Is that you?
Yep. So she mentioned that we are in the process of building a brand new school, and so we're excited about where our engineering lab is going. We feel like we've got a great engineering lab right now with the money that we were able to remodel, but this is going to be spectacular. She's going to have the opportunity. This will be her computer stations, and then she'll have work areas where they can work on projects. Lots of storage. This is now what the prototyping room or the fabrication lab will look like. We're planning on moving the robotics competition table back in the back of the lab now. It won't be in the front. We're going to have a room where we're going to have some laser engravers, some CNC mills, some 3D printers, some different things that the kids can work on individual projects that they want to work on, and that way they can go in. If she's got an intern or a kid that's working on that, they can go in there and work and not disturb what's going on in the class. And then we're going to have we're super excited about a place to store our materials. It's just crazy how you don't have enough closet place to put stuff. Our Southwire Engineering Academy. This thing is phenomenal. We are finishing up our 5th year, and we are just I can't say enough about Southwire because Southwire, it was one of those things where Southwire, what we run into with our internship programs is the lawyers and getting those 16, 17, 18-year-old kids on their floor. And Southwire's brass basically told their lawyers to sit down, that they've got this. Don't worry about it. We'll sign whatever paperwork we've got to do. And so that's what they do. So at this point in time, we've got 24 students that go over there. Right now, we're a modified block. We're an AB. And so on A day, 3rd and 4th block, we have 24 students. And right now, they're in the process of putting their applications in for next year. And we'll sit down. We have a team that we put together. Miss Austin is on the team. I'm on the team. Dr. Albertus has been on the team. Miss Brooks' husband now will rotate to that spot on the team. We have some of our math teachers. We have some of our science teachers that come in, and we will go through the applications. They're required to write an essay of why it would be important for them to go over to Southwire. They have to, go through what STEM classes have you participated in, what extracurricular STEM activities have you participated in. And so it's an application process because it's really important for us to find those kids that are truly wired like an engineer. Because if you teach engineering, that's a different bird. That's not your normal bird walking around. They're wired differently than other kids. And we find that out because we'll have kids that we think have potential, and we will talk them into being a part of the Southwire Engineering Academy and find out they're really not wired like an engineer. And so one of the things that we're doing this year is we're telling them we're not recruiting anybody, because we've gone out and recruited some of our all-stars to do it. And we've made it known this year, if you don't apply, you're not going to be an option. We want those kids that want to be over there. Because our first group 5 years ago, they set the bar so high. I mean, it was a phenomenal group. And so every year, there's a lot of pressure on those kids to not drop the ball and not let that standard go down. And it's tough because every class is different. One of the other things that we're doing this year, up until this point, we've had 18 seniors and 6 juniors in the program. So we would take 6 juniors so that the next year you've got a group of leaders that can merge them up on the interstate a little bit faster. But when you do that, every year you're cutting out 6 kids that didn't get to be a part of the program because that next year they're taking up 6 spots too. So this year we're going to try something else. Next year it will be all seniors. And our hopes is, over 5 years, that's 30 more kids that get to go through the program. So our juniors this year, or our sophomores, they're going to be juniors. Ooh, you talk about mad at me. Now, they were upset, and I flat heard from the 2 or 3 that have been banking on it, that had brothers and sisters go through it. Every one of them called a meeting, and they were hot with me. And one of them would have whooped my butt if I'd have let him. But they take them over to Southwire, and they put them with their engineers. Mike Schmitto is a 21-year veteran of Southwire engineer. He is one of their higher ups, and he's the leader of that program. He every other day he is there directing our program and directing these kids and showing these kids and teaching these kids. And he's got a team of younger engineers and older engineers. It's a great mix of veteran engineers and kids just out of college that work with these kids. Miss Brooks' daughter got to go through it, and even though Katie is not going to be an engineer as she goes about her career, I think she benefited greatly from it. Just the problem-solving aspect of it, and team skills, and just the things that come from it. But they take them in and they give them real-world projects. There's no making copies. There's no going to get coffee or whatever. They're flat. They're taking projects that they've got to do anyway, that they would normally give to the new engineers coming on board. They give it to these group of kids, and these group of kids work on it all year. And it is absolutely amazing to watch these 17 and 18-year-old kids go over there, and they can't speak Southwire. And I'm just going to tell you, it's a cult, and they speak a certain way. And those kids, when they come out in May and they do their final presentations, they stand up there and they sound like 20-year veterans of Southwire. It's the dangest thing I've ever seen. It doesn't take me long to figure out they're a lot smarter than I am. I would have never been a part of the program. They just knocked me out. Just to kind of show you, These are the projects that we've done over the last 5 years, and if you look at them, you can see this ain't getting coffee, this ain't making coffee. It is flat getting after it. This one is probably one of my favorite because we've done 4 of them now. You can actually go to the App Store and you can download an app for Southwire, and 4 of those apps were completely done by our kids. And it's just absolutely amazing. The first year that we did this, and like I said, this was an all-star group this year. The first year that we did this, Southwire at the end of the year said, we've calculated that these kids have saved us about $850,000. And I think their lawyers quickly told them, stop talking about that. Don't talk money no more. And so every year, it's that kind of money because it's time. A lot of the projects they do is cutting down on time that their assembly lines are down. And for Southwire, time is money. And so everything that our kids can do, whether it be develop a board that makes a changeover quicker, to analyzing a video, they'll go out and they will go out in the plant and they will video these changeovers and break them down and problem solve of how to make it faster. How can we make it faster? And 10 seconds is a lot of money. And especially every changeover, when that 10 seconds is over a week, that's more money. When it's over a year, it's even more money. And so it is absolutely amazing at what they do. This was 2012 and 13, and you can see it's the same type of stuff, same type of programs and problems that they're doing. This is a plant. This is the plant, and this is corporate, basically. So we have 2 that work in the corporate office, 2 groups, and then we have 4 groups that are actually out in the plant. Southwire buys them steel-toed boots every year. Every year in September, I'll load them up on a bus. We'll go to the barn store. We'll let them go in. They get to pick out their steel-toed boots. Southwire puts it on their MasterCard. They buy them all laptops. We go into a war room. I'll show you the war room in a little bit. It's what we call it. Every one of them have a laptop when they get there to work on. It's very professional, very, very real world. And the coolest thing, this is 13 and 14, 14 and 15. This was a project where they did a value stream map of an entire section of their plant. You had 4 different groups working on separate projects, and when it all came together, it was one big board. And you see what this project, what this group's did, what this group's did, what this group's did, what this group's did, and it was really cool. And then this is this year's. This one, Georgia Power, Southwire has kind of reached out to Georgia Power. Georgia Power obviously is one of its big partners, and Georgia Power has gotten involved. And so this particular group, Southwire was toying with the idea of going with electric, going green. Going green is a big deal with Southwire. And so they've got gasoline-powered forklifts in their plant. And so they've been toying with the idea of going with the electric, going with the green. And so this group, that's what they did. They went and they studied and they analyzed and they did cost analysis and they compared the batteries and the workload availability and all that. They sat down, this group of kids sat down with the guys at Southwire that probably make $2 million a year and gave them their estimate, gave them opinion on what they had said. That's amazing. I can't even get in the room with those guys. And they're sitting there telling them what they think they should do. This is the war room. This is kind of STEM day to day. I don't have any pictures of them working out in the plant because Southwire is very protective of their machinery. Obviously, we have to be very careful of the pictures we put out there. Anything that we do with Southwire, I have to ask them, can I use this in a presentation, and they'll give me a go or no go. Like there's an article that Georgia Power has written. Well, right now it is with the Southwire attorneys to make sure that the wording is right, and then they will send it back to us, and they'll send it to us so that we can post it on that Weebly that we showed you at the beginning. We'll put all that stuff up there. But this is where 4 of the groups work. It's just kind of their workroom, and they've all got a workspace. They've all got their laptops. Down at the end of the room, they've got the cabinet where they keep their steel-toed boots and everything that they need for that day. And so this is where a lot of them will work. Now, they don't spend a ton of time in here because based on what line they're on, what project they're doing, they'll be out in the plant taking measurements. They'll be out interviewing the workers at Southwire, whatever they need to do that day. And they've got the engineers from Southwire that's guiding them. they ask them, okay, so how could we do that? So how could you do that? Who would you want to talk to? And so then they can point them in that direction. And then this is the room over in the corporate office. They usually have two, but these two groups were kind of working together this day. This is them preparing for their walkthroughs. And here's their walkthroughs. Every quarter, all of the teams are there. All of the members of the team from Southwire, the big brass that are helping us from Southwire, and the Carrollton administration, our group, are there. And each one of these groups have to get up and go through a presentation of, this is what we've done, this is where we're at, this is where we're going. And it's just like the Southwire engineers have to do. They have to do the same thing. And so these kids are putting these presentations together, and they're scripting, and they're talking, figuring out who's going to talk about what, and everything. This is one of the projects. This is a cutter that our kids are helping them to develop, and they have drawn it in SolidWorks, and then they have printed it out on 3D, and they're going to present it to Southwire. Southwire is going to get a patent on this cutter. And that's one of the things they have to do. They have to sign an IP contract that everything that they create and do, Southwire owns. And so these kids, there's a bunch of them, a lot of the engineering folks from Southwire, their badge of honor at Southwire is how many patents they have. And so we've got several kids that have patents with Southwire because of this. So it's really cool. These are some of their presentations. I'd pull these up, but you can see them. They're very professional. And how they go through. It's something that you and I would do if we were having to present out to our bosses. And then the E to E's, and this is my favorite. Before all of this happens, what they will do is they will bring in a mechanical engineer from Southwire, or they'll bring in an industrial or an electrical or whatever. And before they get started with that day, this engineer will tell these future engineers what they do. What classes they took. If they went to Georgia Tech, they'll go through the classes that they took. They'll tell them what was hard, what was not hard. They'll talk about their senior projects. They'll talk about what they had to do once they got to Southwire or wherever they went to school. We have a lot of them went to Southern Poly, Kennesaw now. A lot of them went to Georgia Tech. Mike Smithville went to Tennessee. Some of them went to Auburn. A lot of the big wigs at Southwire are Auburn grads or Georgia Tech grads. And so one of the things that they do, they arrange for us to take the kids to Auburn. We go to Auburn, which I'm an Alabama guy, Roll Tide, by the way. So last year I wore my Alabama t-shirt. I had this shirt on, as a matter of fact. I had my Alabama t-shirt on, so when I got to Toomer Corner, I opened up my shirt and had my Alabama thing. Had it made Toomer Corner. That was awesome. But we went to Auburn, and they take them on a tour, and Auburn gives them tips on what they can do in their essays to give them a better chance to get into Auburn. And Georgia Tech's different. And if there are any Tech grads, I don't mean that negatively. It's hard to get them to spend a lot of time with a bunch of high school kids. So what we were able to do, there's, like I said, several of them over here that went to Georgia Tech, they just cut us loose. And so those Tech graduates that knew where the labs were, knew what happened in those labs, they took us all over Georgia Tech. And they were able to give those kids, this is what you do here. This is this class. This is this professor. Stay away from that professor. This is where you're going to live. And it was awesome. Now, Georgia Tech one of the things that they do is they give you some tips on what you need to put in that essay that's going to give you a better chance. And the way I sell it for our Southwire kids, because it's a recruiting. The first year, it was me in the summertime calling these kids up and say, hey, we've got something we're going to start up. And it was like being a college recruiter, and it was a lot of fun. And so we sat down and we listed out our 30 top guns. And so we're going to try to get 20 that first year. Well, nobody turned me down. And the first thing I did was sold their mamas and daddies on it. And now the way I sell it is, you're all 4.0 kids, you're smart kids, but you've got to have something that's going to separate you from them other 4.0 kids. And I said, this type of thing that does it. There's nothing like this in the country. I've Googled it. Try it. Southwire. If you know anything about Southwire, you've heard of 12 for Life. The 12 for Life program is Southwire's partnership with the Carroll County schools. It is more at-risk kids. It is those kids that are struggling to stay in school. They've got things that happen, and it is an outstanding program. And that is their partnership with Carroll County. This is the opposite end. These are those high-flying kids that need an enrichment, something that's different. And so they have been great partners. But the E to E, at the end of it, it's a competition. In this particular day, this is an assembly line, and they put constraints in it, and the kids have to compete. Let me tell you something.
they will kill you to win this. I mean, they'll brag about it. If you go back to those presentations, the very last slide is how many E2E they've won. Like there's one that they've won 3 in a row. By God, they put it in their walkthrough too to let everybody know. And they've got a cup. Southwire got them a trophy cup, and they fill it full of candy, and that candy stays in there to the next E2E, and it is something. They get after it now, and it's like she said, they'll accuse them of cheating and whatever. So it's a lot of fun. If you need more information from us, this is 3 great places to go. The Southwire Engineering Academy website is just southwireea.com. And you can just Google it, it comes up. It's just southwireea.com. And then the easiest place to me is the chs-stem.weebly.com. That is that document piece that we put together, and you can get to anything that we do STEM is in there. There's a whole section on the Southwire. There's a piece on Miss Austin, how to get to her class, and then this is her Twitter account at Trojan STEM. So that's kind of us in a nutshell. If you had any other questions, this is our email addresses. There's been a change, like I said. Dr. Ken Edwards was the superintendent. He's going home to Nebraska. And so Mark Albertus, who is our principal that's going out, is going across the road to be the superintendent. Coach David Brooks is becoming our new principal. He's an AP with me right now, an athletic director. He's moving to the principalship. She's staying an engineering teacher, and I'm staying an AP. So, but that is all of us. Are there any questions or anything that we can answer for you?
I do want to interject something. You mentioned my daughter Katie did go through the Southwire program, and her major is PR and communications. The great thing about Southwire is those kids who are a part of that program, they want them to come back.
Yeah. They
have already approached Katie about coming back when she graduates to work in their PR and communications department there at Southwire. So, you know, she did an internship out of college, went back and worked for the summer in their PR department there. And so she's got opportunity there when she graduates from Georgia. So, you know, it's not just, even if that engineering is not their segue and not where they're going to major, they do offer those kids and talk to them about coming back and work for their company.
They're growing their own employees. Every one of our kids have been offered a summer job, and they bring them back, and most of them do. Most of them take them up on it because they pay them well. It's great networking. The ones that can't come home, they find them internships where they're at, whether it'll be in Clemson or wherever. They're finding them internships. Bess Glanton, our first class, that 5th year class, this is the year they graduate, and they've hired the first one back. Bess Glanton was a part of the very first one, and they just signed her to a contract, and we've got several others that are. We've got the guy in the video, the first guy. He is planning on going back to Southwire and working. There's several of them, and it's like she said, there's a business side to Southwire as well, and so a lot of them are coming back to that business side. They have a Facebook page where we're all a part of the Facebook page, the brass and the members of Southwire are, and the alumni, and that's the only ones that are in there. It's a way for us to all keep up with each other and see where, because we've got them spread all over. We've got one in Yale, we've got a couple out in California, Vandy, Virginia, they're just Georgia Tech, Auburn, they're all over the place, yeah. So it is a neat thing. They love for guests to come in, so it's one of those things, if you ever wanted to see it, just contact me and I can set up whatever, as long as it's an A day, I can tell you what the A days are, and we can pick a time, and you can come to the school and I'll drive you over and get you in, and they'll let you look and see and do, and they share. I mean, a lot of folks have come to see them because a lot of folks are trying to duplicate this. It's just hard. It's hard because a lot of folks won't get those lawyers out of the way. They won't cut them loose, and they've done a great partnership.
Thank you so much.
Absolutely.
Appreciate it.